you know, you'd think I would have this like YouTuber, videographer thing down, but that's really, for lack of a better term, team, that's just not my spiritual gift. Hey team, I'm Maddie. Welcome to Science Sci It Up, and today we are talking about climate change and its effects on Arctic sea ice. So yes, I am over at my desk instead of in front of my chalkboard. Please forgive this mess. I'm working on a quilt, and this is also my sewing room. So this website that we're on right now, the National Snow and Ice Data Center, at least for the US, this is a super great resource if you're interested in anything related to the cryosphere. So I've said a few times that I'm talking about sea ice, and I think when I say sea ice, a lot of people picture in their heads like glaciers or icebergs. That's not the type of ice I'm actually talking about. I'm talking about sea ice. So this is the ocean itself freezes in the winter, and some of that melts in the summer, and then it refreezes in the winter, and it's a whole thing. Note that there's always some ice still around. We will hit an ice-free summer sometime this century, but predictions for that don't get more precise. Well, they do get more precise, they just don't get more accurate. So this is just the homepage for the NSIDC. This is actually also where I get a lot of my data for my graduate research. It should be free and available for like anybody and everybody. So this is our homepage, and I will link this page in the description if you want to go play with this yourself. So there's lots of things, right, that they keep data sets for: snow, glaciers, ice sheets, sea ice shelves, soil moisture, frozen ground. Like I said, anything cryosphere related, they've got data for it. But we are super interested in this sea ice. So with our sea ice's annual cycle, it has the smallest sea ice extent, right? So we have the least amount of ice in September. Oh, these are data sets. This is not what I wanted. Sorry, I wanted pictures. And Arctic Sea Ice News and Analysis. There we go, that's the link I want. So we reach our minimum extent in September, and our maximum extent is in March. So you can generally think of ice as melting from March to September and accreting or growing from September to March. Okay, so this is a great graph. This is a really great graph for just a snapshot of what's happening. In Bigify, please. Thank you. Okay. So this is from the 1st of January to the 30th of December, sea ice extent. So that's like the area. If we took a string and dragged it around the sea ice edge and measured the area inside of it, that's what sea ice extent is. So what you're looking at is this blue line here, that is this year. So that's what's happening right now. The red dashed line is 2012. 2012 is a special year because it's still our record minimum sea ice extent. So 2012 holds the record. And then this dark gray line is the the median, and not the average. It's the medium, so it's sort of the most common values for those days. And that's between 1981 and 2010. So when we're talking about climate, if we want to compare what's happening today to what sort of happened in the past or what normal would be, you typically pick a 30-year time period, because if you take an average over 30 years, that's going to get rid of things like decadal cycles or variations in INSO from one year to the next, right? So if you take a 30-year average, you're getting a pretty good sense of the climate, the average climate, without being overly affected by shorter time scale processes. So a simple way to think of that is if we look over the last, say, 5 years, right, maybe we had a weird record cold winter or something like that, or record hot summer. But that's by definition an anomaly. That's not normal. So if we want to get a sense of what normal winter temperatures are for your region, we just want to take an average over a long time. And again, in climate, a climatological mean is generally an average over at least 30 years. So the first thing that I think we notice when we're looking at this is how different 2012 was from this like reasonable average state, right? It was super, super, super different. And you might be thinking, well, like that's an extreme, maybe something weird happened that year, and something kind of weird did happen that year. There was the Great Arctic Cyclone of 2012. But check out, like 2012 is holding on to this record by the skin of its teeth. There's 2018, here's 2019. Notice those like minimums creeping down. Here was 2020. 2020, we got close to breaking and we did not. Right, so my point here being, here I'll pop 2013 up on there too. So if you look at 2013, yeah, there's a huge difference between 2013 and 2012, that pale green line and the dark red dash line, right? 2013 is on the low end of our average range, you know, but 2013, gosh, that was almost a decade ago now, right? So, you know, as time has progressed, we're getting noticeably just less and less sea ice in that September minimum. And another really important thing that I think is less noticeable is the March value. Check out, so let me pull some of these guys off. Here we go. Look at, because remember March is when we have a maximum. So look at this blue, that's this year, and the dark green, that was last year. We're starting to get less and less sea ice at our maximum. So the swings in September sea ice have been happening, that's sort of been more noticeable, but up until the last few years, March sea ice extent has been pretty consistent. But now, not only is our minimum getting less and less and less and less, our maximum is also starting to get less and less. So that's really interesting to me. And that's really very, very direct. There's a direct causal link between the warmer air and less sea ice. And we know that this is made worse by our ice albedo effect, right? We did a video on that. So when we have ice is shiny, so it reflects sunlight. We know that the albedo at the pole is almost twice that what it is for the average of the planet. Hi team, I found the video I was looking for. Sorry, I totally should have had that pulled up. I'm a little scatterbrained today. It's a fine. So what we got here is a nice GIF that shows you how sea ice has changed from 1979 to 2020. And I don't know if I've said this before, but for Arctic data, we don't really look at anything before 1979, or we don't look at much, because 1979 marks the start of the satellite era. So we don't have many, if any, observations from before 1979 for the Arctic. So our when we start looking, generally starts there. So check this out. This should be, I think this is our summer extent through, so this is like the minimum extent through time, right? So we're gonna step through here, and keep going. Okay, so here we are at 2020. This was our like minimum September extent in 2020. So look at this image, and now let's think back to that 1979 value. Look at that. It's a huge, huge difference, right? We're talking millions of square kilometers different. So why did I bring up Arctic sea ice? Apart from it being like one of my favorite things on the planet. Climate skeptics like to bring up with Arctic sea ice is, well, past predictions said we would have an ice-free summer by now. Yeah, guys, like our forecasts, our predictions for when we'll have an ice-free summer and ice-free September is sometime between this year and the end of the century, right? It's not this year. It also probably won't be the year 2100, right? It's gonna be somewhere in between. And it hasn't happened yet, but it is happening, right? That's very obviously where we're moving towards, but forecasting exactly when sea ice is going to kind of be gone, at least in the summer, is hard. And let me show you why on that one. So popping back to NSIDC, here's for April. This is the average monthly Arctic sea ice extent, April 1979 to 2021. So black is the average value and blue is the trend, right? This is very clearly decreasing, right? But there's a lot of wiggles in our graph. There's a lot of variation in the signal, or variance, to use our good statistics words, right? So we oscillate about this trend a lot. So the trend, that linear line, that is climate change, right? That's what that signal is. That is global warming happening before our eyes. The less understood processes, which make it really hard to forecast when will we have an ice-free summer, right, are what causes the wiggles, right? So we understand the trend. We're actively researching and working to understand the variance about the trend, but not understanding the full mechanisms of the variance doesn't mean we don't understand the mechanism of the trend, right? Trend is global warming. The wiggles we're less sure about, right? And that's partially why I have a job, right? This is what I'm studying, if you guys were wondering. Okay, so I like to bring that up because like I said, there's a couple very common climate skeptics type arguments about Arctic sea ice and stuff like that. So I wanted to kind of show you, I think the climate change and how it affects Arctic sea ice is very clear, right? And I think you can see that in like images, you can see that in the data, you can look at it and see it. So I thought you guys would like that, especially after we talked about all that ice albedo effect. You know, you guys put in some good work on understanding the science, and I wanted to reward that with pretty pictures, I guess. Okay. I think that's all I've got for this video. So I will see you back over at the chalkboard. Okay, team, that's all I've got for you today. I hope you and those you care about are well. If you are so inclined and able, there's a link to my Buy Me a Coffee fund down below. Currently, I'm saving up to get a portable air conditioner for my office so I can still film in here in August. So I'd appreciate that. Again, if you guys are like willing and able and want to financially support my channel, that'd be great. I'm real bad at shilling. It makes me very uncomfortable, but otherwise, please like, subscribe, be kind, and I will see you all next time. Okay, bye team.